The project consisted in a series of graphics and functions used to emphasize the outline of a Coke bottle and to determine the volume of the 3D figure. We use different types of functions in order to best describe the edge of the bottle that my friend will explain later.
Hi, this is our Coca-Cola bottle project. In order to know the volume of the Coca-Cola, we sketch some equations in Desmos. That in next we will use to find out the volume of Coca-Cola by using this method formula. In the first equation, the purple one here, we use a square root that was like 8 times x in a square root to do the graph a little bit thinner, but to have a more height. Next, we use a negative quadratic square, a little bit flat. Next, the orange one, this one, we use an orange square. And was very flat. We multiply it by 1/29. Next, we use this flat line in our equation. Then we use another one here, little, to give a little bit of shape to the ball. And this one has a very difficult. This one, it's a polynomial function. This polynomial function, we did it because it was more accurate and was only one equation, and we want to have less equations. So we use this, and the only case here is to have the point inflection that you want. This point inflection, we will need to change it a little bit. You need to play with some details here, some points, and just kind of accurate our job.
The formula we used was volume equals pi times j squared with the respective limits, but the originally was radius, but we decided to change by j. The first function we take the volume was j this one, that it represents the bump at the bottom of the bottle, and the volume was 91.063 units cubic. Then the second was root square of 8x plus 1, that it represents the very bottom of the bottle, and the volume was 1.45 units cubic. The third one was J equals 3.16 with a volume of 1081.94, and it represents the medium part, the medium red line of the bottom of the bottle. And the fourth one was J equals 1 with a volume of 4.71 units cubic. Then is this function that it represents the concavity of the bottom of the bottle with a volume of 168.79 units cubic, and the last, the function we used was this one with a volume of 93.20 units cubic, that it was the part before the end. Then we added all the volumes we have already, and the result of the final volume was 541.1299 44 units cubic.